Talk about instantaneous velocity now. This is Mr. Sand. And I just want to show you a curve right here. I'm starting off right here. And this is really to figure out to um, how to find an instantaneous velocity without using calculus. If you have a position versus time graph like this, then here's how you figure out a particular instantaneous velocity at any time point along here. Instantaneous time point is, or an instantaneous velocity is when the time interval approaches 0. So we're going to find a point on here where there is a velocity. And along all of this curve right here, you can see that the velocity is changing gradually, and then it changes gradually here, changes gradually. And the steeper the slope at any point, the faster the object is going. And that can be faster in this direction. Looks like this is probably the fastest point, probably right about there, going positively. And there's also a most negative slope, and that's probably right about there at that time point. But let's just say that there's a time point, I don't know, I'm just going to point right here at that particular point, right there. And I want to know what the instantaneous velocity is at that particular point, whatever point that is. And I can make up values, but I'll just call this time, we'll just call that time z. That's time z seconds. At z seconds, what is the velocity of this object that's moving around with this position versus time graph? Well, to figure this out, you need to find a tangent. And I don't have a straight edge with me right here. Well, I guess I could approximate it. I guess this is going to be very difficult, but I'll try. I'll try to approximate this. All right, so I'm going to try to draw a tangent line that's something like this. Something like that. You're trying to find the tangent line, just like you'd find a tangent line of a circle. If you have a circle, I'll draw a really quick circle right here. It's not going to be ideal. And you want to try to find a tangent line of this circle. You would try to find a point, or you try to find a line where it just crosses one point of this circle and nowhere else. A tangent line over here would be something like this. So you're just approximating right now. I'm not going for the most perfect accuracy, but you'd be surprised. Most of the time, if you have graph paper and a straight edge, you can find a really, really close approximation of the instantaneous velocity. You'd be surprised how close it could be. So anyway, this is the point, and this is the instantaneous velocity at that point. Now, what I've done right now is I've just drawn a straight line. And like any straight line on a position versus time graph, you can find a slope of that straight line. And it's just like the way that we found a slope before using our y equals mx plus b formula. And the y, well, just using that equation and then finding the slope, finding this point, right, or finding the m value, which is the slope, which is the change in y over the change in x. So what you need to do is you need to find, well, if we chose this point right here, we can choose another point anywhere along here. I could say this point right here. This point right here is going to have a value x something, or some seconds. So I'll just say some t final, or sorry about that. I mean some x seconds. That's at this point right here, and it's going to have some y meters. And over here, this point right here, I'll just call it x2 seconds and y2 meters. That's this second point over here. Okay, so we've got 2 points on this tangent line. And now all we have to do is find the slope of that tangent line to find the instantaneous velocity. So to do that, it's a change in y divided by the change in x. The change in y is going to be, I'll just write change in y over change in x. That's our slope. The change in y is going to be y2 in terms of meters minus y1 in terms of meters all over x2 in terms of seconds. Oops, I put meters there. Minus x1. I don't think I put a 1 here, but I'll put a 1 right there. 1. x1 in terms of seconds Okay, there it is. And whatever this value is, that's going to be my slope of this line. And so what I can do is I can even interpolate or extrapolate using this equation right here. But really, when I say what is the instantaneous velocity, all I'm really talking about is the slope. So I want to find that on this line, this slope, which is the change in the y value over the change in the x value. So it's going to be the change in meters over the change in seconds. Or if it's not meters, it's going to be like centimeters or some kind of description of position. Okay, so let's use a real life warm-up problem right here. So it says, consider the position versus time graph of Ben running to first base for the following problems. I'm just going to do the first problem with you. It says, calculate Ben's instantaneous velocity at 1 second and 3 seconds. The tangential line is already drawn for you. So at 1 second, it's already drawn for us. That's awesome. And 3 seconds, well, I'll draw that one in. So I'll draw that one in right now. So here's a line from a word processing document at 3 seconds. So I'm going to go to 3 seconds. It's right here. And my line isn't perfect that I have here. So I'm going to make it thicker. I'm going to make it a different color. I'll make it blue. Right. And I'm going to make this line really as close to tangential as I possibly can. So at 3 seconds. Oh, it's snapping into place. Darn it. I don't want it to snap. Why is it snapping? I was trying to go to a 45-degree angle. It's not exactly a 45-degree. This is going to be harder than I thought it would be because of the snap. Oh no, Apple, why do you do this to me? Okay, let's just say that it is at this angle right here. This is the tangent line. Actually, no, let's not do that. I'm going to do something slightly different here. I'm going to just take a quick screenshot of this and use this in the drawing program. Hold on. Okay, I'm going to close this. And here's a screenshot. Don't save. Okay, so it's already drawn for us here. I'm going to draw the tangential line as close as I can to 3 seconds. So again, 3 seconds right up here. And I'm going to try to draw it. Okay, whoops. Right about like that. About like even a slighter. I'll go back here. A little bit steeper at 3 seconds. It's going to be something like that. Okay, so the purple line there is the slope approximately at 3 seconds. And this right here, the green, is the slope at 1 second. So to find the instantaneous velocity, find the slope at 1 second. So at 1 second, let's see where he would be in terms of his position. You can look at the graph and it really helps. And that's about 7 meters. I'm going to say it's about 7 meters there. So at 1 second, he's gone 7 meters. On this curve right now, I'm going to pick a different point. I'm going to make it easy on myself. I'm going to choose a whole number. I'm going to look at 2 right here. At 2 seconds, where has he gone? He's gone about, I'd say it's like 18 meters. So for his instantaneous velocity at 1 second, right here, which is this green line, this is the tangent at the green line, here's the equation you use. You use, let's see, the change in y over the change in x. The change in y is going to be 18 minus 7 all over 2 seconds. This is in terms of meters. 2 seconds minus 1 second. So this is going to be an easy calculation for us now. 18 minus 7 is 11 meters, I think. And 2 minus 1 is 1 second. So it's 11 meters per second. That's for 1 second. Now for 3 seconds, I'll use a different color for 3 seconds. I'm going to use sea foam for 3 seconds. So 3 seconds, let's look at what there's a point at 3 seconds. And I'm going to say he's about 52 maybe? I'm going to say 52, round to 52 meters. That's how far he is. And then I'm going to use this line. I'm using the purple line again. I'm going to go let's use a purple line. I'll use the grape. Extend this purple line. This is really hard to do freehand all the way past 4 seconds. Okay, and I'll see what that is on the position. So at 4 seconds, which is right about there, he is approximately, I gotta say, that's like 76 meters. So for 3 seconds, his change in Y value is 76 meters minus 52 meters. And his change in time, which is this X value, is 4 seconds minus 3 seconds. So this is meters and this is seconds. So 76 minus 52. 76 minus 52. 76 minus 52 is 24. This is 24 meters per 1 second. So that is his instantaneous velocity at this point, and it's much different than it is at this point. And that's great because you can see there's a difference in the velocities. If you're taking the average velocities, you have to sum over all of these velocities here, and you would just get an average view. But here you can see it's drastically different. He's 11 meters per second at that point, and he's 24 meters per second at that point. Very, very, very different velocities. And yeah, that should help you solve all the problems in this section. So good luck.